Hello everyone, let's take a look at our next problem. A deck of 40 cards consists of 4 1s, 4 2s, all the way up to 4 10s. A matching pair, which is 2 cards with the same number, is removed from the deck. Given that these cards are not returned to the deck, let m over n be the probability that 2 randomly selected cards also form a pair, where m and n are relatively prime positive integers. Find m plus n. Okay, so this should be a fairly straightforward thing to compute, given that we more or less know exactly what the contents of the deck are after the 2 cards are removed. So there's no loss of generality in saying that the 2 cards that are removed are both 1s. So we now have a deck that have 4 2s, 4 3s, all the way up to 4 10s, and 2 1s. And it should be straightforward to compute the probability that we draw a pair. Okay, so let's first compute the probability of drawing. And of course, so if we're saying that the 2 cards that are removed are both 1s, then the probability of drawing 2 2s, or 2 3s, or 2 4s, and so on are the same. But the probability of drawing 2 1s is different. So we'll have to compute these probabilities in 2 different ways. So the probability of drawing both of the remaining 1s will be 2 out of 38 times 1 out of 37. So that's the probability of getting matching 1s. Now let's compute the probability of getting matching 2s. In fact, I'll call this the probability of getting matching n's, where n is any number from 2 to 10. This is going to be 4 out of 38 for the first card that's drawn, times 3 out of 37 for the second card that's drawn. So this gives us 12 out of whatever this product is. And how many different ways are there of drawing matching n's? Well, there are 9 values of n here, which apply. It's basically every number from 1 to 10 except for 1. So the probability of matching should be 2 divided by 37 times 38 plus 9 times 12 divided by 37 times 38. Starting to think I might have a mistake here because the final answer to the question has to be less than 1,000, but I'm getting at it's slightly greater than 1,000. Did I do this product correctly? I didn't, apparently, but I'm still not getting something reasonable. Oh, goodness. I'm mixing up sums and products and everything. 703, not 1003. Because for some reason I'm slow today, I'm going to do this again in different order. Make sure I get the same number. 9 times 7 is 63. 7 plus 6 is 13. 9 times 3 is 27. 5, 3. Yes, okay. So 703 plus 55. 55 and 703 are relatively prime. You can see that from here, right? 37 and 19 are both prime. The numerator is 5 times 11, both of which are prime. So this gives us 758. So where could my mistakes possibly lie if part of my logic with computing the probabilities doesn't work here? I hope that's not the case, but there could be a source of error there, or if I did some of the arithmetic incorrectly, I did go through it pretty quickly, there could be a mistake there. If I spot one of these mistakes or if I have any additional thoughts, I'll write them up in the description. Otherwise, thanks for watching.